Hi there, class. Welcome to our last unit, our condensed unit on measurement and geometry. Our first lesson is going to be looking at introduction to angles. And so the first thing that we need to look at is naming angles. So what we need to do is we need to, as you can see here, we've got three letters, A, B, and C here. And we're going to use those to describe the middle portion between the angles, and that's the vertex, which is right in that middle point. And when we are naming that, a big thing to take note is that it doesn't matter if we start with A or C, as long as B is in the middle. So wherever that vertex is, that letter has to be in the middle. So notice how we have this here. We've got this little funny symbol, which is the symbol for an angle. So angle ABC, or we can write it as angle CBA. Notice that the B is always in the middle, so that always has to be there. So that's our big takeaway from naming angles. Whatever the letters are, use three of them to form an angle, and the vertex is always that middle point. All right, so now let's take a look at some types of angles. So we've got our three distinct main angle types that we have. I'll go over the names first. We have acute, we have right, and we have obtuse. So the easy ways that I always use to remember it is, so the first one for acute is between 0 degrees and 90 degrees. And as you can see, it's a little cute angle. So it's acute angle. So that's the way I always remember it, that it's small and cute. The next one, 90 degrees, that's the right one. So hopefully we can remember whenever we see that box that that's a right angle. And then that means that the actual angle size is 90 degrees. And anything that's bigger than 90 degrees, so 90 to 180, because 180 is a straight line, it's no longer an angle. So anything from 90 to 180 is an obtuse. Think of it as being really wide. It is very obtuse. So that's how I always remember them. Now we have 180 degrees, which is our straight line. We have a reflex, which goes past 180 degrees. So anything from 180 to 360, that's a reflex. So that's past a straight line. And anything that goes 360 degrees, that's a full revolution. So that's a full spin around. So you can always refer back to this. Take a look in your notes. For this is a very important chart and table for you to remember in terms of types of angles and in terms of when we are naming them. So next thing we're going to look at is we are going to use the following diagram to answer the questions below. So we have our diagram right over here. A whole bunch of different angles. We see a bunch of different things in there. So we're going to be naming some of them. So what is the vertex between P, D, and E? So I'm going to look for P, and I'm going to go to D, and then over to E here. And I see that we're going like this. This looks like it's smaller than 90 degrees, so it's acute angle. What's another name for the angle? Well, we could use EDP, right? So we could do it backwards, so that would be another name for the angle. So it's acute and it's EDP. Classify the following angles. So APD, so APD, that looks like it's past 90, so that must mean it's obtuse. Our next one is CPD, so we start with C, P, and then we go up to D. Oh, that's just a straight line there, so straight. And angle DPB. So DPB. Oh, that looks like it's less than 90 degrees, so that means it's acute. It's a little acute angle. All right, next we are going to give an example of a revolution angle. So we have angle 0, right? So it's 360 degrees, so it would be coming back to itself. So we could write it as A0A, so that would just be like A, then nothing, then A. So just to spin around on that point. Or we could also write it as PAP. So starting at PAP, so we've gone all the way around and back to P. So that's two different ways that we can do a revolutionary angle. Next, we're going to look at a summary of angle relationships. So the first one we have is we have opposite angles, and this is when we have an X pattern in any kind of angle. So anywhere that we see an X, we'll see opposite angles. So angle A and angle B, those angles are the same number, they'll be the same degrees, and C and D will also be the same degree. So you don't have to measure them. Once you know one of them, you can figure the other one out. Next up is alternate angles. And alternate angles always have a Z pattern. So you can see that they're alternating in which inside they're on. So this one's on the bottom, and that one's up at the top. Right? This one's on the left, and then that one's on the right. So they're on the opposite side. So they're alternating. And those angles are the same when we see this Z pattern on an angle, just like we saw in the example above here, right? Wherever we see Z pattern, whenever we see the X pattern as well, we can figure out which ones are the same. So the insides, and then that one again, we've got both of those bigger ones. So we see that these look like they're acute angles, and these ones are both obtuse angles, but they are always equal. Corresponding angles, these ones are a little bit different. They're similar to alternate with differences, obviously. So these ones are forming an F pattern. So when we come from a point, we come to the middle, we come down. So we've got this F shape here. Now you see that they're both underneath a line. I would say underneath a line. And they're both on the same side. So that's the difference, right? They're not on the opposite sides, they're on the top and on the bottom. These ones are the same, so they correspond. They're corresponding to one another. So they form an F pattern. And these ones are equal. So where we see this little T, that's our angle sign on there. Those two angles right here would be the same. Same with on this side here, the top part. Over here, we have those angles are the same. These angles here would be the same, all the ones that correspond with one another. All those would be the same angles, same degrees. Now we've got co-interior angles. So now this one is where we get a little bit more math with our angles. So these ones are both, you can see that they're both on the inside. So co means two or both, and interior means on the inside, and so they're both here on the inside. And we see that these angles will always add up to 180 degrees. So once you find one of them, we can use math to figure out what the other one is. We don't need to use a protractor or anything like that. We can use math because we know that both of those two angles will add up to 180. Now there's one more thing that I want to go over before I move along, because it's something that I've skipped past, and that's these bolded words. We see these transversal and parallel lines. You're probably looking on your sheet and wondering, Mr. Stevens, what are those? So I'm going to go back up and I'm going to go through again with you just to make sure that we don't miss it or see it. Don't catch it. So formed when a transversal intersects two parallel lines. Well, we can see parallel lines. We know a parallel line from previous years is that they're running in the exact same direction and they will never ever touch. So parallel means that they're running at the same degrees, that they will never intersect. If they were a little bit closer in, eventually down the line, they would hit, then they're not parallel, so these will always stay the same. So our transversal line is that line that comes down in between those two parallel lines and it almost connects the two of them. That's our transversal line. So again, so we've got corresponding angles is formed when a transversal intersect two parallel lines and forms an F. So we see that, so we have our parallel lines and then our transversal coming down, and we see that we're getting an F pattern there. Whereas before with our alternate angles, again, it's formed the same way, but we're looking for Z patterns for alternate angles, F patterns for our corresponding angles, and so on. So I just wanted to point that one out because that's the last one that makes a shape or where we really see it. So using those transversal and parallel lines. And those are two terms that you are going to use in future math as well. All right, so back onto our math. We have supplementary angles. And this is formed when a line segment intersects a straight line. So we have our straight line down here and we have a line that just comes through. And we see we've got A and B here. Well, if we were to figure out with a protractor what this degree is, and if we were to then add it to what B is, it's going to add up to 180 degrees. And we know that because we know that a straight line from one side to another is 180 degrees. So A plus B, that will equal 180. So supplementary, 180. And complementary is when two angles is formed when a line segment intersects at a right angle. So we have our right angle here, and we always know it's a right angle. You always see a box there. You always see a box, and that's how you know it's a right angle, so 90 degrees. So again, wherever this line is, whenever we add up A and B, we should get up to 90 degrees. And then we're going to be able to use math for both of those, because if we're given one, we can figure out the other one, and we never have to measure them ourselves. So we're going to go over a few examples, and then I'm going to leave you guys to your practice questions. So our first example, what is the complement of 35 degrees? And what is the supplement of 35 degrees? So complement, we know that that is when it adds up to 90 degrees. So we just went through that. So that means that we know that our total has to equal 90. So we know that A plus our 35, which we can see right here. So if we have 35 plus, or A plus 35, both of those are going to equal 90. So we can use our algebra skills. So we want to single out our variables. So we see plus 35. So opposite is subtract 35. So 90 minus 35 gives us 55. So the complement of 35 degrees is 55 degrees. So in the supplement, the easy way that I remember it is supplement. You want to be supplemented with more money, more allowance. So supplement with more. So 180 is more than 90 degrees. So hopefully that'll help you remember 180 degrees for supplement. So again, same way as before, we have 180 equals A plus 35. So we need to subtract out our 35. We're left with 145. So the supplement of 35 is 145. Okay, so now use the charts above, and you're going to use all of these above, and you're going to answer the following questions below.